In our first project, we'll be connecting an LED to our Raspberry Pi. We'll essentially be demonstrating how the LED can be powered from one of the power pins on the Raspberry Pi. And if you remember from our GPIO pin layout discussion, the Raspberry Pi has a couple of pins that can be used as power pins, two 3.3 volt pins and also two 5 volt pins. We'll be using the 3.3 volt pins. One note of safety and caution is that always power off or ensure your Raspberry Pi is powered off before connecting any circuitry and peripherals with GPIO pins. This is a good safety precaution, as if you touch a GPIO pin, you can short them out or you can connect two pins by accident and permanently damage your Raspberry Pi. Believe me, that has happened to me before and you don't want to make that mistake. So please ensure that your Pi is powered off, connect your circuit, double check it, then power up your Pi, and that is the safe way to work with circuitry. So what are we going to need for our project? First of all, of course, the Raspberry Pi and the associated peripherals. Also, a breadboard is handy in working with external peripherals and just making quick connections. So always have a breadboard handy to quickly wire up your components. We'll need a couple of wires. These are female to male connecting wires, and they're pretty convenient in that one end can quickly connect to a pin on the Raspberry Pi and the other end can be plugged into a breadboard. So these make connecting components to your Raspberry Pi very easy and a breeze. There are links provided to these in the parts list for the course, so please feel free to check those links for online retailers that you'll be able to purchase these female to male connecting wires from. You'll also need a resistor, and here I have a 330 ohm resistor. You can also use a 220 ohm resistor, but you need some sort of resistance for your LED in order to limit the current flow to the LED so it doesn't burn out or doesn't damage your Raspberry Pi. Next, of course, you'll also need an LED, and any type of LED will work. So just get a LED of your choosing or color, and that's all we should need for our first project. Let's take a look at our circuit diagram. This is extremely simple and very basic, and just a couple of connections that we need here. So essentially, here's our Raspberry Pi, and this is the number 1 pin, number 2, 3, 4, and so on. That's the convention that we're using. So from the number 1 pin, we are going to our 330 ohm resistor, and the other end of that resistor is connected to the anode or the positive pin on our LED. The negative pin of our LED or the cathode is connected to the ground pin or one of the ground pins on the Raspberry Pi, and in this case it's the pin number 6. So that's our circuit diagram, fairly straightforward, and now we're going to look and see how we wire this up. Now let's go ahead and wire up our circuit. So the first connection we're going to make is to the 3.3 volt pin on our Raspberry Pi, and if you orient the Raspberry Pi with the USB slots at the base, pin 1 is the pin at the top left. So at the top of our Pi to the left, that should be our pin 1, which is our 3.3 volt pin. So I'm going to take one of my wires and connect it to that pin. The other end goes to the breadboard, so you can place that anywhere on the breadboard. Next up, we'll connect our resistor. So I'm going to take the resistor. And remember, on the breadboard, we want to make sure that the resistor is connected in the same row as our wire. So I'm just going to go ahead and make that connection now. The other end of the resistor can go anywhere else on the breadboard. Next up, let's connect our LED. And remember, for an LED, it has a long pin and a short pin. The longer pin here at the top is the anode or the positive pin, and the shorter pin below is the cathode or the negative pin. When you're connecting an LED, polarity matters. And in this case, the positive pin, or the anode, has to be connected to the end of our resistor. So just ensure that it's connected along the same row as the end of the resistor, and the other end of our LED, or the cathode, goes back to ground, and that is the pin 6 on our Raspberry Pi in this case. So I'm just going to put that connection in there. Remember, it's in the same row as the cathode, and the other end goes to pin 6, which is the third pin down on the right on our Raspberry Pi. So on the right, 1, 2, 3, I'll make that connection there, and that should be it. So that's the connection for our circuit. It's now complete, and we can proceed to boot up our Raspberry Pi and see if our LED lights. So now that our Raspberry Pi has been booted up, if you'll notice, our LED is lit. So the 3.3 volt pin is powering our LED. Current is coming out of the 3.3 volt pin into our resistor, into the anode of our LED, out of the cathode, and back to ground. And that's completing the circuit and powering our LED. So now our LED is being lit and powered from our 3.3 volt pin. It just illustrates that these power pins can be used to power external peripherals and components connected to our Raspberry Pi. Hope you liked this simple example, and we'll move on to now in the next phase, we're going to programmatically control our LED.